Hey folks, let's go ahead and take a look at example 2. It's pretty similar to example 1. We're going to change things up a bit. So in this particular example, we want to figure out when is this rational expression greater than or equal to 0. Okay, great. So this already has a 0 here, no problem. My next thing that I'm going to do is I'm going to set x plus 1, right? We're going to set the numerator and the denominator to 0. If I subtract 1 from both sides, I'm going to get x equaling -1 here. Right? Or I'm also interested in when x is equal to 4. Add 4 to both sides. So these are two interesting x values. If I plug -1 in, I zero out my numerator, and 0 over any number would be 0. So that is a 0 of that rational expression here. And if I put 4 into my rational expression, I zero out my denominator. That's actually going to be a domain issue, so that rational expression doesn't exist when x is 4. So once you've set your numerator and denominator to 0 and solve for x, your next step is going to be to make a number line, right? We're going to go ahead and make a sign pattern, and I'm looking for my ruler. Oh, found it. So let's go ahead and make a number line, right? Our sign pattern. You can think of your sign pattern as just a smushed up x and y axis. All right, so I'm going to go ahead, draw that line in here. And I'm going to go ahead and make sure you know me, I like things properly labeled. So I'm going to put x below the x-axis, and then our y's, or our function, if you will, our rational expression of x plus 1 over x minus 4. Okay, and we're going to create this sign pattern. And when I say sign pattern, we're going to keep track of where are things positive, where are they negative, where are they 0, and then maybe where don't they exist. So my two interesting numbers are -1 and 4. And so here's how we do this, right? When x was -1, if I plug -1 into this, right, I get -1 plus 1, which is 0. 0 over -5 is 0. Okay. When I plug 4 in, I get a 0 on the denominator, so that rational expression does not exist at x equaling 4. So whatever numbers are down here, right, whatever x values you have, to get the sign pattern, you're plugging them in to this expression. So once we get there, we want to use test points. We basically have 3 intervals. If you think the left side goes to -infinity, right side goes to infinity, we have this interval from -infinity to -1, and I have another one from -1 to 4, and then another one from 4 to infinity. And in order to solve this, I just want to see how many of these 3 intervals do I want to include. Do I want to include all 3? A lot of times it's either the outer 2 or the middle 1. Right? Maybe it's the middle and the right. It just depends on the inequality. But we're going to pick test points. And I usually start over here. So I'll pick something like 5. I need any number larger than 4. And all I'm keeping track of at this point is positives and negatives. Right? So this, again, is called a sign pattern. I don't actually care about the y value itself. I don't care how above the x-axis or below the x-axis. I don't care about that up-down motion. I just care, did I go up or did I go down? So let's try 5. 5 plus 1 would be positive. 5 minus 4 would also be positive. And a positive in ratio to a positive is positive. Okay? I can pick any x value between -1 and 4. All right, and when I do that, let's try 0. I like picking 0. Okay. If I plug in 0, 0 plus 1, positive, but 0 minus 4 changes and becomes negative. Okay. And a positive in ratio to a negative is negative. Okay. And then last but not least, let's pick something. Ooh, that is blurring up. Let me see if I can get that to focus. Sometimes my camera goes out of focus when things are too bright. All right, let's pick anything in this interval. I'll go with -8. So -8 minus, -8 plus 1 is negative. -8 minus 4 is also negative, but a negative in ratio to a negative is positive, right? So I'm going to go ahead and erase all my little scratch work. And eventually you'll get to the point where you don't need to write these test points, right? When we practice enough, we'll start to see quite literally patterns, all right? And let me start to explain a little bit of, well, actually, I'll wait till the end and I'll explain the pattern. I'm going to show you how I get this sign pattern, this plus minus plus, with doing very little plug-in work, okay? So now when I go back to my original inequality, it's saying where are things greater than or equal to 0. So I want to collect where are the plus signs and the zeros. So I got a plus, a 0, and a plus. So I want to write up those x values. So I want this left interval, and I want this right interval. Okay, and because this is greater than or equal to 0, I do want to use a bracket, right? Because I want to include -1. And ideally, I'd like to put a bracket around 4, but that's the domain issue. So I can't put the bracket around 4, even though there is the greater than or equal to 0, because it's not 0 here, right? The fraction itself is undefined because the denominator is 0. So it's okay for a numerator to be 0, not okay for a denominator to be 0. So I'm going to put the bracket here and the parentheses here. Ultimately, my answer is going to be -infinity to -1 with a bracket. Right? Infinities always get the parentheses. That's the first interval. And then I want to go from 4 to infinity. Okay, so I have to put the parentheses around 4 because 4 doesn't, or if I plug in x equaling 4, that fraction doesn't exist. Okay, so maybe after 2 examples, you started to see that these signs alternate, right? Plus, minus, plus. The same thing happened on example 1. And I'm going to tell you, when you have factors, you have an x plus 1 here and an x minus 4 here. When you have factors that are to an odd degree, meaning if I were to put parentheses around this would be to the first power. This would also be to the first power. When you have when you have factors that are raised to an odd degree, the signs will alternate. So I knew this was either going to go plus minus plus or minus plus minus. All right, to counter that, if you had something like x plus 1 squared, the sign would not change around -1. Then it would have gone plus plus minus, right? So it wouldn't have changed around -1, but because x minus 4 was to the first power, it would have changed here. All right, so when you have odd powers, everything alternates. If you have even powers, the sign stays the same. So if this was plus, then this would be plus, right? If this was minus, this would be minus. Now we don't have that in this case. And the other thing that helps me do this a little bit quicker is I usually start here when I do my test points. You might have noticed that, because this I can deduce without a test point. How I do this is I look at the lead terms on numerator and denominator, and the numbers in front of them are +1 over +1. If that ratio is positive, this is going to be positive, right? So how I would have done this, right, without test points, just to kind of give you a preview. Let's say this was blank and I didn't do test points. Here's how I do this relatively quickly. I look at these lead coefficients, they're positives, so I know there's going to be a plus there. And then I look that these are raised to odd degrees, so I know the sign is going to alternate. And that's how I get through that sign pattern that much more quickly. And we'll keep reviewing that time and time again until we get the hang of it. All right, thanks so much. Bye.